What would happen if a massive solar flare hit Earth today? This question might have crossed your mind recently, thanks to NASA's observation of an enormous sunspot on our solar surface. Bigger than our own planet, this sunspot is a cooler, darker patch that could be seen with the help of eclipse glasses. But what are sunspots exactly? They're areas on the sun's surface that are cooler and darker than their surroundings, and they're not just interesting to look at. They can also be precursors to solar flares, intense bursts of radiation that the sun emits. Right now, our sun is heading towards a peak in activity, a phase known as the solar maximum. As we near this phase, the potential for solar flares increases. If a solar flare were to occur, it could potentially disrupt communication and power systems on Earth. Solar flares are not new phenomena. In fact, one of the most significant solar flares ever recorded happened in 1859. This event, known as the Carrington event, set a precedent in our understanding of solar physics. It was not just a solar flare, but also a massive coronal mass ejection, or CME for short. This CME was so powerful that it caused a geomagnetic storm on Earth, changing our perspective on how the sun and its activities can influence our planet. Now, what exactly happens during a solar flare, or a CME? Essentially, the sun ejects a burst of energy and charged particles into space. This energy can travel all the way to Earth, where it can interfere with our planet's magnetic field. Here's where things start to get interesting and, well, a bit concerning. These charged particles from the sun can induce electric currents in our magnetic field. You might be wondering what that means for us here on Earth? Well, these electric currents have the potential to wreak havoc on our infrastructure and electronics. Imagine a world where our communication systems are disrupted, power grids fail, and our technology-dependent society grinds to a halt. This is not a scene from a science fiction movie, but a very real possibility in the event of a powerful solar flare, or CME. The Carrington event of 1859 gave us a glimpse into this potential reality. It served as a stark reminder of our vulnerability to the sun's activities and the importance of understanding and preparing for such solar events. But it's not all doom and gloom. By studying past solar events, like the Carrington event, scientists and researchers are better equipped to predict and prepare for future solar flares and CMEs. This knowledge is our first line of defense in protecting our technology-dependent society from the potential impact of these solar events. Understanding these solar events is crucial in preparing and protecting our technology-dependent society from their impact. But how would a solar flare specifically affect our communications and possibly astronauts? Solar flares are not just celestial light shows. They pack a punch that can ripple across our technology-dependent society. These solar outbursts can send waves of electromagnetic radiation towards Earth, disrupting our communication systems. Imagine, 1 minute you're streaming your favorite show, and the next, your screen goes blank. Or you're on an important call, and suddenly, you lose signal. That's the kind of interference we're talking about. Now, let's turn our gaze upwards, way upwards, to the astronauts in space. They're even more exposed to the sun's tantrums. The charged particles from a solar flare can pelt spacecraft and potentially jeopardize the safety of those on board. It's like being caught in a cosmic hailstorm, with particles traveling at nearly the speed of light. Sounds scary, doesn't it? But don't worry, we're not entirely at the mercy of the sun. Both our communication infrastructure and astronauts have protective measures in place. For instance, satellites and communication networks have redundancies and shielding to safeguard against solar flare-induced disruptions. As for the astronauts, they're not just floating around unprotected. Space agencies like NASA monitor solar activity closely. In case of a solar flare, they can direct astronauts to shielded areas within the spacecraft. They've even got specially designed spacesuits that offer some protection against solar radiation. It's like having your personal bunker in space. In essence, while solar flares can cause some hiccups in our daily lives and pose risks to astronauts, we're not entirely defenseless. We've got strategies and systems to counter these cosmic curveballs. We're continually learning, adapting, and preparing for these solar events to ensure the safety of our technology and our explorers in space. While solar flares pose a genuine threat, Measures are in place to safeguard our communication systems and protect astronauts. With the recent observation of the enormous sunspot and the sun approaching its solar maximum, where does that leave us today? Our current scenario is a fascinating yet challenging one. We find ourselves at a critical juncture where a celestial body, the sun, is treading its path towards the peak of its activity. This phase, commonly known as the solar maximum, is expected to reach its pinnacle this year. NASA's Solar Dynamics Observatory recently observed an enormous sunspot, wider than Earth itself, on the surface of the sun. These sunspots, cooler and darker areas on the sun's surface, are often precursors to solar flares. Solar flares, as we've come to understand them, can be quite disruptive. They can wreak havoc on our communication systems and power grids, potentially plunging us into a state of darkness and disconnection. And it's not just us Earthlings who are at risk. Astronauts, our brave explorers of the cosmos, could also face significant threats from these solar outbursts. The charged particles emitted during these events can pose grave dangers to their spacecraft and their health. But it's not all doom and gloom. Humanity has always risen to the challenge, and this situation is no different. In the face of a potential solar flare, we have scientists and researchers working round the clock to understand, predict, and mitigate the risks associated with these solar events. Just like in 1859, when the Carrington event marked a significant moment in solar physics, we are prepared to learn and adapt from any solar event that comes our way. We have the tools, the technology, and the tenacity to face this head-on. Our understanding of solar flares and their impact has improved exponentially over the years, and we are better equipped to handle their potential impacts. Our preparations are not just limited to Earth, they extend to the safety of our astronauts in space as well. While the threat of a massive solar flare is real, rest assured that scientists and researchers are working tirelessly to mitigate its potential impact on our planet.